What if everything around you, the stars, the planets, even the empty space between them, wasn't just dead matter, but alive and aware? What if the universe itself had a kind of consciousness, a vast, shimmering web of thought woven into the fabric of reality? It sounds like science fiction, but some of the brightest minds in physics and philosophy are seriously considering this possibility. Welcome to the frontier of quantum consciousness, where the boundaries between science and spirituality blur, and the universe might not just be something we observe, but something that observes us back. For centuries, we've assumed consciousness was a fluke, a rare spark in the cold void of space, limited to biological brains. But what if that's only a tiny piece of the puzzle? Quantum consciousness theories suggest that awareness might be fundamental to reality itself, as built into the cosmos as gravity or light. Imagine a universe where particles don't just collide randomly but choose, where the act of observation doesn't just measure reality, it shapes it. This isn't just philosophy. It's a radical rethinking of physics, one that could explain everything from the eerie behavior of quantum particles to the mysteries of human perception. In this video, we're diving deep into 30 of the most mind-bending theories about the universe's quantum consciousness, ideas that challenge everything we think we know about existence. From the holographic principle to panpsychism, from quantum entanglement to the notion that time itself might be a kind of thought, we'll explore the cutting edge of science and metaphysics. Whether you're a skeptic or a believer, these concepts will stretch your imagination to its limits. So buckle up. By the end of this journey, you might never see the cosmos or your own mind the same way again. One of the most startling ideas in quantum consciousness theory is the notion that the entire universe might function like a giant thinking mind. Picture this: billions of galaxies, each filled with trillions of stars, entangled in a cosmic dance where every particle communicates instantaneously, not through physical force, but through something eerily similar to thought. Physicists exploring this concept suggest that the universe's structure resembles a neural network, with quantum entanglement acting like synapses firing between distant neurons. It's as if the cosmos isn't just a cold, mechanical system, but a vast, interconnected web of awareness. At the heart of this idea is Roger Penrose's controversial Orch-OR theory, which proposes that consciousness arises from quantum processes happening inside the tiny microtubules within our brain cells. But here's the twist: Penrose and others speculate this quantum activity isn't confined to biological brains. Instead, it might be a fundamental feature of reality itself, woven into the fabric of space and time. Imagine the implications. Every particle interaction, every collapse of a quantum wave function, could be a flicker of proto-consciousness, like microscopic thoughts bubbling up from the void. This theory challenges one of science's deepest assumptions, that consciousness is just an accidental byproduct of complex chemistry. If the universe truly behaves like a quantum mind, then awareness isn't something rare or special. It's everywhere, embedded in the very laws that govern existence. Stars might not just burn, they might process information. Black holes might not just devour matter, they could be cosmic nodes in an unimaginably vast thought process. Suddenly, the ancient idea of a living universe doesn't sound so mystical. It might just be the next frontier of physics. If the universe truly possesses some form of consciousness, it could solve one of science's most perplexing mysteries: why the laws of physics seem so perfectly fine-tuned for life. Think about it: the precise strength of gravity, the exact charge of an electron, even the delicate balance of forces inside atoms. If any of these were off by the tiniest fraction, stars wouldn't shine, molecules wouldn't form, and life as we know it couldn't exist. The odds of these constants aligning by chance are astronomically low. But what if they're not random at all? What if the universe isn't just obeying mindless laws, but selecting them, like a cosmic architect fine-tuning its own blueprint? This idea dovetails into the hard problem of consciousness, the baffling question of why and how subjective experience arises from mere matter. Traditional science struggles to explain why we don't just process information like robots, but actually feel the warmth of sunlight or the sting of pain. Panpsychism, the view that consciousness is a fundamental feature of reality, offers a provocative answer. Maybe the universe never had to invent consciousness from scratch because it was always there, woven into the fabric of existence. Atoms might not think like humans, but they could carry a faint glimmer of awareness, like the hum of background static in a vast cosmic mind. Imagine the universe as a self-adjusting system, where the laws of physics aren't fixed but evolve toward stability. In this view, consciousness isn't an accident, it's the universe's way of exploring itself. Just as natural selection shapes life over time, a sentient cosmos might select laws that allow complexity, curiosity, and even self-reflection to emerge. It's a breathtaking thought. The same processes that light up stars could also be nudging reality toward ever deeper layers of understanding. Suddenly, the universe isn't just a cold machine. It's more like a grand experiment in awareness, with each of us as tiny sparks in its unfolding thought. John Wheeler's Participatory Anthropic Principle turns our understanding of reality inside out. What if the universe doesn't just exist independently, waiting to be observed, but instead requires observers to bring it into being? Wheeler, the legendary physicist who coined the term black hole, proposed that consciousness isn't a passive spectator but an active participant in shaping the cosmos. At the quantum level, particles exist in a haze of possibilities until measured, a phenomenon called superposition. But Wheeler took this further, suggesting that the act of observation doesn't just reveal reality, it creates it retroactively. This mind-bending idea finds eerie support in delayed choice experiments, where a particle's behavior seems to change based on measurements made after it's already traveled its path. Imagine firing a photon through a slit and only later deciding whether to measure which slit it went through or to let it behave like a wave. Astonishingly, the photon's past behavior adjusts to match the future measurement, as if time itself bends to accommodate our choices. It's as though the universe waits for conscious observers to make up its mind, rewriting history on the fly. Wheeler saw this as evidence that the cosmos is a self-excited circuit, a grand feedback loop where observation and existence are intertwined. In his vision, the Big Bang wasn't just the beginning of time. It was the first question in a cosmic dialogue, with every conscious being since then contributing answers through observation. This isn't mere philosophy, it's a radical fusion of quantum mechanics and metaphysics, suggesting that without minds to observe it, the universe might remain an unmanifest sea of potential. The implications are staggering. If Wheeler was right, we're not just living in the universe, we're helping to dream it into being, one quantum decision at a time. But if the universe is truly conscious at some level, how does it decide which experiences become real? Why do we all agree the sky is blue or that gravity pulls us downward, rather than perceiving an endless fog of quantum possibilities? This brings us to Wojciech's revolutionary idea, quantum Darwinism. Picture evolution, but not of living creatures. Instead, imagine quantum states competing for survival, where only the most stable, most observable ones persist long enough to shape our shared reality. Dirk's theory hinges on environmental decoherence, the way quantum systems interact with their surroundings, causing wispy superpositions to collapse into definite states. Think of it like this: when a quantum particle is left alone, it can exist in multiple states at once, like a spinning coin mid-air. But the moment it bumps into something, air molecules, light particles, even other atoms, that interaction selects one state to become real, just as the coin lands on heads or tails. Over countless interactions, certain states prove more resilient, more likely to be copied and spread through the environment. These are the quantum fittest, the states we end up perceiving as objective reality. The parallel to biological evolution is striking. Just as natural selection favors traits that help organisms survive and reproduce, quantum Darwinism suggests reality itself favors states that can withstand observation and leave the clearest imprint on their surroundings. The redness of an apple isn't just a property of the fruit. It's the result of trillions of photon interactions broadcasting that particular wavelength into the environment until it becomes inescapable. Even our own consciousness might be shaped by this process, filtering the noisy quantum soup into the stable, shared world we experience. What's truly fascinating is how this theory bridges quantum weirdness with everyday perception. Schrödinger's cat can't stay both alive and dead because the environment measures it continuously, reinforcing one outcome until all observers agree. In this light, consciousness isn't just observing reality. It's participating in a grand, dynamic process where quantum possibilities compete for the chance to become real. The universe isn't passively waiting to be seen. It's actively broadcasting certain states while others fade like forgotten dreams. Some physicists speculate this could explain why we perceive time flowing forward. The arrow of time might emerge from quantum states being continuously selected and stabilized, like frames in a film stacking up to create the illusion of motion. If Jacques is right, then the world we see isn't just the only possible one. It's the version that won the quantum competition, surviving endless interactions to imprint itself on our minds and the cosmos alike. The implications ripple outward. If consciousness plays a role in this selection process, then reality isn't just something we discover. It's something we help create moment by moment through the very act of perception. Imagine if every thought you've ever had, every sensation you've ever felt, wasn't confined to your brain, but was instead a tiny fragment of a vast cosmic hologram projected from the edges of the universe. This is the radical premise of the holographic principle, a theory that suggests reality as we know it might be nothing more than an illusion, a three-dimensional movie playing on a two-dimensional screen at the boundary of space itself. And here's where it gets even wilder. If the universe truly functions like a hologram, then consciousness might not emerge from our brains at all, but from the universe's grand information processing system, where every bit of data is meticulously encoded on the fabric of space-time. The roots of this idea stretch back to black hole thermodynamics. When matter vanishes into a black hole, it doesn't just disappear, its information gets imprinted on the event horizon, the point of no return, like a cosmic fingerprint. Leonard Susskind and Gerard T. Hooft realized this wasn't just a quirk of black holes. It might be a fundamental feature of reality. They proposed that the entire universe could work the same way, with all the information about everything inside it, every star, every planet, every human thought encoded on its outer boundary. Picture a soap bubble. The swirling colors on its surface aren't random. They contain all the information about the liquid inside. In the same way, our three-dimensional reality could be a projection from a two-dimensional surface we can't even see. But how does this connect to consciousness? Think of your brain not as the source of your thoughts, but as a receiver tuning into signals from this cosmic hologram. Just as a television translates electromagnetic waves into images and sound, your mind might decode universal information into subjective experience. This flips traditional neuroscience on its head. Instead of consciousness being generated by neurons firing, it could be a fundamental feature of the universe's information structure, with our brains merely acting as intermediaries. The implications are staggering. If the holographic principle holds, then every decision you make, every memory you cherish, might be part of a vast computational process happening at the edge of existence. Even time itself could be an emergent property, like the frames of a holographic movie giving the illusion of motion. Some researchers speculate this could explain déjà vu moments when your mind briefly glimpses the underlying code, like spotting a glitch in the simulation. Others suggest it might solve the binding problem, the mystery of how disparate brain processes unite into a single, seamless experience. Perhaps consciousness feels unified because it's all being rendered from the same cosmic source code. Susskind himself once compared the universe to a quantum computer with the holographic boundary acting as its hard drive. In this view, black holes aren't cosmic trash compactors. They're the universe's way of processing and storing information like celestial servers. And if that's true, then every time a star collapses into a black hole, it's not being destroyed. It's being uploaded into a grand cosmic database, its data preserved forever on the event horizon. This theory blurs the line between physics and metaphysics, suggesting that the universe isn't just conscious, it's literally thinking in patterns of information. The equations governing quantum mechanics and general relativity might not just describe reality, they could be the universe's own language, its way of processing and interpreting itself. And we, as conscious beings, might be more than just observers. We could be active participants in this cosmic computation, our awareness acting as nodes in a network spanning the entire hologram. Suddenly, the ancient idea of as above, so below takes on a startling new meaning, not as mystical dogma, but as cutting-edge physics. The universe isn't just out there, it's in here, in every thought, every perception, every flicker of awareness that makes us human. What if consciousness could be measured like temperature or pressure, a physical quantity with real, calculable properties? That's the bold claim of integrated information theory, or EIT, a framework that doesn't just ask what consciousness is, but how much of it exists in any given system. Neuroscientist Giulio Tononi proposed that consciousness isn't binary on or off, but exists on a spectrum quantified by a value he calls phi. The higher the phi, the richer and more unified the conscious experience. A human brain with its billions of interconnected neurons would score high. A thermostat with its simple feedback loops would barely register. But here's where it gets cosmic. What if phi doesn't stop at biological brains? Could entire galaxy clusters with their intricate gravitational dances possess a phi value high enough to qualify as conscious entities? Tononi's theory starts with a radical premise. Consciousness is the capacity of a system to integrate information. Think of it like a symphony. A single violin playing alone has low phi, it's just one voice. But an orchestra where every instrument responds to the others, creating harmonies richer than any solo, has high phi. The magic lies in the connections. In your brain, it's not just the neurons firing that matters, but how their activity influences one another, weaving a unified experience of, say, the smell of rain or the sting of a needle. Phi measures this interconnectedness mathematically, calculating how much the whole system knows that its individual parts don't. Now stretch that idea to the cosmic scale. Picture a galaxy cluster, thousands of galaxies bound by gravity, their motions influencing one another across millions of light years. The gravitational interactions between them are unimaginably complex, a constant exchange of information shaping their orbits and collisions. Under IIT, this isn't just physics, it's a potentially conscious network. The cluster's phi value would depend on how deeply its components are interwoven, how much the system's behavior relies on its internal relationships rather than external forces. A loose group of galaxies drifting independently might score low, but a dense, interacting cluster, that could be the universe's version of a brain, a slow, cold, sprawling mind operating on timescales we can barely fathom. Critics argue that applying IIT beyond biology is a stretch. That consciousness requires more than just complexity, but specific kinds of information processing, like those found in neural tissue. Yet if phi is truly universal, then the line between thinking and non-thinking systems blurs. Stars exchanging gravitational signals, black holes storing information on their event horizons, even the quantum vacuum seething energy. Could these processes, given enough integration, birth something akin to thought? The universe is full of feedback loops, from the spin of planets to the life cycles of stars. If consciousness is fundamentally about self-referential information, as IIT claims, then the cosmos might be alive in ways we're only beginning to imagine. Imagine a galaxy cluster thinking at a glacial pace, its neurons separated by light years, its thoughts unfolding over eons. What would such a mind experience? Perhaps the gravitational ebb and flow of dark matter, or the slow-motion ballet of spiral arms, or maybe something entirely beyond human analogy, a form of awareness as alien to us as our inner lives are to a grain of sand. Tononi's phi metric doesn't answer these questions, but it gives us a tool to ask them scientifically. If consciousness is indeed a matter of integrated information, then the universe might be whispering to itself in a language of gravity and light, its grandest structures humming with a faint cosmic awareness. Beneath the surface of what we perceive as empty space lies a seething ocean of energy, the quantum vacuum. Far from being truly empty, this vacuum crackles with activity, a froth of virtual particles popping in and out of existence so fast they barely leave a trace. But what if this ceaseless dance isn't just random noise? What if, as physicist Erwin Laszlo proposed, the quantum vacuum is more like a vast, conscious field, a cosmic memory bank he called the Akashic field, where every event, every thought, every vibration in the universe leaves an imprint? Laszlo's idea builds on the zero-point field, the lowest possible energy state of space. Even at absolute zero, when all classical motion stops, quantum mechanics tells us this field still thrums with fluctuations. Particles flicker into being for infinitesimal moments, borrowing energy from the vacuum itself before vanishing again. Mainstream physics treats these as mathematical quirks, but Laszlo saw them differently as the universe's proto-thoughts, tiny pulses of potential that could form the basis of a universal consciousness. Imagine each virtual particle as a fleeting spark of awareness, like individual neurons firing in a brain too vast to comprehend. Collectively, they might weave a web of meaning, a substrate where information isn't just stored but felt. This isn't pure speculation. Experiments in quantum optics have shown that the vacuum isn't passive. It reacts to observation, producing detectable effects like the Casimir force, where unobserved virtual particles create measurable pressure between plates. If the vacuum can respond to measurement, could it also, in some rudimentary way, anticipate? Some theorists suggest these fluctuations might form a kind of quantum code, with patterns repeating and evolving over time, a cosmic habit memory, as Laszlo put it. Ancient traditions spoke of the Akashic records, an ethereal library of all that ever was. Laszlo's hypothesis gives this myth a scientific twist. The vacuum itself might be that library, its fluctuations encoding the history of the universe like grooves in a cosmic record. Consider virtual particles as the universe's raw material for thought. In your brain, consciousness arises from electrical patterns, neurons communicating in precise sequences. On a cosmic scale, vacuum fluctuations could play a similar role, their brief, chaotic interactions building up to something greater. Just as trillions of synapses give rise to your inner world, quadrillions of quantum events might coalesce into a diffuse, universe-spanning awareness. It wouldn't think like we do with words or images, but in a language of probabilities and resonances, a hum of potential waiting to collapse into reality. The implications ripple outward. If the quantum vacuum is conscious, even in a primitive sense, then the fabric of space itself might be more alive than we ever imagined. Black holes could be knots in this cosmic mind, their event horizons processing information like neural networks. Dark energy, the mysterious force accelerating the universe's expansion, might not be a blind force but an expression of this field's intent. A vast, slow decision to keep exploring its own possibilities. Even times arrow could emerge from the vacuum's tendency to remember some states and forget others, like a mind discarding irrelevant thoughts to focus on what matters. Skeptics argue that calling the vacuum conscious stretches the definition of awareness beyond usefulness. Yet Laszlo's framework offers something rare, a bridge between spirituality and quantum physics. The Akashic field isn't a ghost in the machine, it's the machine itself, humming with a quiet sentience we're only beginning to decipher. Whether you see it as metaphor or mechanism, one thing is clear: the void isn't empty. It's awake. Robert Lanza's biocentrism flips the script on reality with a startling proposition: what if space-time isn't the stage for life but a product of it? At the heart of this radical idea lies a simple but profound shift. Instead of treating consciousness as an accidental guest in a pre-existing universe, biocentrism suggests that life itself is the architect, shaping the very fabric of reality through observation. Picture a painter who doesn't just fill a blank canvas but creates the canvas with every brushstroke. According to Lanza, this isn't just poetic metaphor, it's how the universe actually works. The roots of biocentrism dig deep into quantum mechanics' strangest quirks. Take Schrödinger's infamous cat, trapped in a box where it's simultaneously alive and dead until someone peers inside. Traditional physics treats this as a puzzle about measurement, how observation collapses quantum possibilities into a single outcome. But Lanza goes further, arguing the cat isn't just waiting for an observer to reveal its state. The observer determines whether the box even contains a cat at all. In this view, spacetime isn't a fixed backdrop. It's a flexible construct woven into existence by living beings navigating their environment. The implications grow even wilder with Eugene Wigner's lesser-known thought experiment, Wigner's friend. Imagine a scientist in a lab measuring a quantum system, while another scientist stands outside the lab door. For the first scientist, the quantum state collapses the moment they look. But for the second, the entire lab, including their colleague, remains in superposition until they open the door. Who's right? Quantum mechanics bizarrely suggests both perspectives are equally valid, exposing a glaring paradox. Reality might not just depend on the observer, it might multiply based on whose observation you privilege. Lanza seizes on this, proposing that spacetime isn't absolute but relational, branching into personalized realities for every conscious entity. Critics argue biocentrism oversteps, conflating the role of observation in quantum mechanics with the outright creation of reality. Mainstream physics acknowledges that measurement affects quantum systems, but stops short of claiming life generates spacetime. After all, the universe existed for billions of years before any observers arrived. Or did it? Lanza counters with the anthropic principle. Perhaps those early eons only seem to have happened because we're here to reconstruct them retroactively, like detectives piecing together a crime scene that didn't fully exist until they started looking. Here's where biocentrism collides head-on with classical physics. Einstein's relativity treats spacetime as a smooth, four-dimensional continuum, warped by mass and energy but independent of perception. Lanza's framework, by contrast, suggests spacetime is more like a language, a system of relationships that only makes sense when spoken by conscious beings. Imagine trying to describe a dream to someone who's never slept. Without the shared experience of dreaming, the description is meaningless. Similarly, biocentrism posits that without life, spacetime has no more reality than an unsung melody. The debate hinges on whether consciousness is a passive witness or an active co-creator. If Lanza is right, then the universe isn't just observed, it's authored, one conscious moment at a time. The stars, the planets, even the laws of physics might not be eternal truths, but collaborative stories told by every living thing. It's a vision that blurs the line between science and philosophy, challenging us to reconsider not just where we are in the universe, but what the universe is in us. Quantum Bayesianism, or cubism, turns the traditional view of quantum mechanics on its head by asking a provocative question. What if the probabilities in quantum theory aren't objective features of reality, but reflections of our own personal beliefs? According to physicist Christopher Fuchs, one of Cubism's key architects, the bizarre behavior of quantum particles isn't just an unsolved mystery, it's a mirror revealing how deeply consciousness is entangled with the fabric of reality. In this radical interpretation, every quantum measurement isn't a discovery of some pre-existing truth, but a collaboration between the observer and the universe, shaping outcomes through the lens of subjective experience. At the core of Cubism lies a simple but revolutionary shift. Quantum probabilities don't describe how particles are, but how an observer expects them to behave. Think of it like weather forecasting. When a meteorologist predicts a 70% chance of rain, that percentage isn't a property of the atmosphere. It's an expression of confidence based on data and past experience. Cubism treats quantum probabilities the same way. The famous wave function, which Schrödinger's equation uses to describe quantum states, isn't a tangible thing out in the world. It's a tool, a mathematical crutch that helps you, the conscious observer, navigate uncertainty and update your beliefs based on what you see. This approach dissolves some of quantum mechanics' thorniest paradoxes. Take the infamous double-slit experiment, where particles seem to behave as both waves and particles depending on how you measure them. Traditional interpretations struggle to explain how a single photon chooses its behavior. But Cubism sidesteps the confusion entirely. The photon doesn't choose anything. The wave-particle duality isn't a property of the photon, it's a reflection of your incomplete knowledge. The photon exists in a haze of potential until you interact with it, and that interaction isn't passive observation. It's an active dialogue where your expectations and the universe's response co-create the result. Where Cubism gets truly mind-bending is in its implications for consciousness. If quantum mechanics is fundamentally about subjective belief, then reality isn't just influenced by observers, it's constructed through their perspectives. Fuchs has compared the universe to a cosmic game of 20 questions where the answers aren't predetermined but emerge through the act of questioning itself. In this view, every conscious agent, whether a human scientist or, hypothetically, an alien or AI, plays the game by their own rules, each contributing to a shared but ever-shifting tapestry of reality. Critics argue Cubism risks veering into solipsism, the idea that only one's own mind is sure to exist. But Fuchs insists the theory isn't about isolation, it's about interaction. When two observers compare notes, their personal probabilities can align, creating what we call objective facts. Think of it like two chefs tasting the same soup. One might say it needs more salt, the other more pepper, but through conversation, they converge on a shared understanding. Similarly, Cubism suggests that the stable, predictable world we experience emerges from countless conscious agents refining their beliefs through collective measurement. The real departure from tradition comes when Cubism tackles the role of consciousness head-on. Most interpretations of quantum mechanics treat observers as special but don't explain why. Cubism flips this. Observers aren't special because they collapse wave functions. Wave functions were never out there to begin with. They're internal scoring systems, tools that conscious beings use to navigate ambiguity. This makes consciousness not an afterthought in physics, but a foundational element. The universe doesn't just allow for observers, it's built for them, a vast network of potential awaiting interpretation. Proponents of Cubism point to its elegant resolution of Wigner's friend, a thought experiment where two observers seem to create conflicting realities. In Cubism's framework, there's no contradiction, just two personal perspectives that haven't yet reconciled. It's as if you and a friend wrote separate reviews of the same movie. The differences don't mean one of you is wrong, but that each brought unique expectations to the experience. The universe, in this light, isn't a monolithic truth but a kaleidoscope of intersecting viewpoints, each valid within its own context. What emerges from cubism is a universe that's less like a clockwork machine and more like an ongoing conversation, a cosmic improvisation where every conscious participant adds their voice. The equations of quantum mechanics don't describe a hidden reality behind the curtain. They're the grammar of a language we're all speaking into existence, one observation at a time. Whether cubism is the final word on quantum theory remains to be seen, but it undeniably pulls consciousness from the shadows of philosophy and plants it squarely in the equations of physics. After all, if reality hinges on belief, then the greatest quantum mystery might not be particles or waves, it's us. At the heart of Roger Penrose and Stuart Hameroff's orchestrated objective reduction theory lies a microscopic structure most of us have never heard of: microtubules. These tiny protein filaments scaffolding the interiors of our brain cells aren't just cellular supports. According to Orch-OR, they're quantum computers, orchestrating consciousness through vibrations so precise they dance on the edge between quantum and classical physics. Picture a symphony where each note is a quantum state collapsing into reality, conducted by the delicate geometry of these nanotubes. It's a vision where awareness doesn't emerge from neurons firing, but from quantum ripples pulsing through the fractal architecture of the brain itself. What makes microtubules special? Their structure resembles hexagonal lattices, a geometry Penrose argues is perfect for quantum coherence, the fragile state where particles remain linked across space and time. In this model, electrons within microtubules don't just shuttle chemical signals. They exist in quantum superposition, performing calculations at unimaginable speeds. When these superpositions grow too large, they collapse, a process Penrose calls objective reduction. But here's the twist: these collapses aren't random. They're orchestrated by the microtubule's vibrations, each collapse generating a moment of conscious experience. Think of it like raindrops striking a pond. Each droplet's impact is a fleeting thought, the ripples merging into the stream of awareness. Critics have long dismissed Orch-OR as speculative, pointing to two major hurdles. First, the brain is warm, wet, and noisy, a hostile environment for delicate quantum states that typically require near absolute zero temperatures to survive. Second, even if quantum processing occurs in microtubules, there's no clear mechanism explaining how it translates to subjective experience. Why should a collapsing quantum state feel like anything at all? Yet recent experiments are turning skepticism into intrigue. Studies on anesthetics, chemicals that selectively switch off consciousness, reveal they bind precisely to microtubules, disrupting their quantum vibrations. When patients lose awareness under anesthesia, their brain's electrical activity remains largely unchanged, but the predicted quantum coherence in microtubules vanishes. This eerie correlation suggests consciousness isn't just about information processing, but about how that processing happens at a quantum level. Even more compelling are discoveries in quantum biology. Photosynthesis, bird migration, even our sense of smell all exploit quantum effects in warm, messy biological systems. If nature harnesses quantum mechanics in these processes, why not in the brain? A 2018 experiment published in Entropy found evidence of vibrational resonances in microtubules matching the frequencies Orch-OR predicts. Another study showed that certain anesthetics alter microtubule vibrations at the same frequencies they erase consciousness, while drugs like LSD that intensify awareness enhance these same vibrations. It's as if we're glimpsing the dials on a quantum radio, tuning in and out of conscious states by tweaking microscopic oscillations. The implications ripple beyond neuroscience. If Orch-OR is correct, then consciousness isn't confined to brains. Any system with the right quantum architecture, perhaps even artificial materials designed to mimic microtubules, could, in theory, host awareness. This blurs the line between biology and technology, suggesting future AI might not just simulate thought but experience it. Penrose himself speculates that the universe's fundamental geometry could favor quantum coherence, making consciousness less a biological accident and more a cosmic inevitability. Yet the debate is far from settled. Skeptics argue that even if microtubules exhibit quantum effects, there's no proof these effects generate consciousness rather than merely accompany it. Others propose alternative quantum consciousness models, like Tegmark's criticism that quantum states in the brain would decohere too quickly to matter. But Orch-OR resilience lies in its testability. Unlike purely philosophical theories, it makes bold predictions about microtubule vibrations, anesthetic mechanisms, and even the quantum signatures of awareness. With each new experiment, we're not just probing a theory, we're peering into the quantum whispers that might be the voice of consciousness itself. Ever its many worlds interpretation paints a universe that never chooses. Instead, at every quantum crossroads, it splits, spawning parallel realities where every possible outcome plays out. But here's the haunting question. If every decision forks existence into countless branches, what role does consciousness play in this infinite tapestry? Some theorists propose a startling answer. The multiverse isn't just a mindless fracturing of possibilities. It might be a living network with meta-consciousness governing the branching, like an unseen hand tending the roots of reality itself. The math behind many worlds is elegant in its simplicity. When a quantum particle faces multiple states, traditional physics says observation forces it to pick one. But Everett argued nothing collapses. Instead, the observer entangles with all outcomes, each version of them inhabiting a new, self-contained timeline. Imagine standing before two doors. Quantum mechanics says you don't just choose left or right. You split into two versions of yourself, one walking through each door in a separate universe. But if consciousness is fundamental, as quantum consciousness theories suggest, then these splits aren't just mechanical. They could be meaningful, shaped by a deeper layer of awareness we don't yet understand. This is where the idea of a meta-conscious multiverse takes shape. Picture the universe not as a tree with dead branches, but as a mycelial network, each thread alive and communicative. At the quantum level, every branching point might be more than a random divergence. It could be a decision made by a universal consciousness exploring its own potential. In this view, you and I aren't passive passengers riding the waves of probability. We're participants in a grand experiment, each of our choices sending ripples through the multiverse's broader mind. Some interpretations even suggest that parallel versions of ourselves might remain weakly linked through quantum entanglement, their experiences faintly echoing across the divide. The implications grow stranger when you consider why certain branches might be favored. If consciousness influences quantum outcomes, as theories like cubism propose, then universes where life flourishes could be statistically privileged, their paths reinforced by the very observers within them. This could explain the eerie fine-tuning of our cosmos not as luck, but as the result of a self-selecting multiverse where conscious observation steers reality toward stability and complexity. Imagine a cosmic Darwinism where universes that learn to sustain awareness proliferate while barren branches fade like forgotten dreams. Critics argue this veers into metaphysics, but the math offers tantalizing hints. Quantum decoherence, the process that severs parallel worlds from one another, bears striking similarities to how neural networks prune unnecessary connections to optimize thought. Could the multiverse itself be performing a version of this, trimming less coherent branches while nurturing those ripe with conscious exploration? The boundary between physics and philosophy blurs here, inviting us to wonder whether the multiverse is a machine or a mind, or something in between, vast and aware in ways beyond human comprehension. Perhaps the most humbling thought is this: if the multiverse is conscious, then every version of you in every timeline is part of a vaster existence, a single, sprawling entity experiencing itself through infinite perspectives. The choices you make today don't just alter your future. They might be the universe's way of asking, what else can I be? What if consciousness doesn't just move forward through time like an arrow, but flows in both directions at once, like a river circling back on itself? This is the spine-tingling premise of time-symmetric quantum consciousness, a theory where the present isn't just shaped by the past, but pulled by the future. Imagine dropping a pebble into a pond and watching the ripples spread outward only to realize the waves are also moving backward, converging toward the point of impact before it even happens. Experiments in quantum physics are now revealing hints of this retrocausal effect, suggesting that conscious observation might not just record reality, but reach across time to tweak its very foundations. The evidence comes from delayed choice experiments, where particles seem to decide their behavior based on measurements made after they've already traveled their path. In one stunning variation, scientists fired photons through a maze of mirrors, then randomly chose whether to measure their particle-like or wave-like properties at the last possible moment. Astonishingly, the photon's behavior hours earlier appeared to match the future measurement, as if the act of observation reached back through time to rewrite history. It's not time travel in the sci-fi sense, but something even stranger, a universe where cause and effect aren't fixed chains, but flexible threads that conscious observation can rearrange. This challenges our deepest assumptions about free will. If the future influences the past, are our choices truly ours, or are they echoes of decisions we haven't made yet? Some theorists propose a middle path. Consciousness might be a time-symmetric process, with our present awareness serving as a knot where past and future observations intersect. Picture a sculptor working on a block of marble. From one perspective, each chisel stroke shapes the final statue, but from another, the idea of the finished sculpture guides every strike of the hammer. In this light, our conscious moments could be both the creators and the creations of a reality that exists all at once, spanning from the Big Bang to the heat death of the universe. The implications ripple into cosmology. If consciousness is time-symmetric, then the universe's beginning and end might not be separate events but mirror images. The Big Bang's fiery dawn and the distant future's cold silence could be two sides of the same coin, with conscious observers like us serving as the bridge between them. This might explain why the universe appears so finely tuned for life, not because of cosmic luck, but because life, and the consciousness it carries, is what binds time into a coherent whole. The equations of quantum mechanics already treat time as reversible at a fundamental level. Time-symmetric consciousness simply asks, what if that reversibility isn't just math, but the universe's way of thinking? Skeptics argue this veers into metaphysics, but the math is gaining traction. Quantum physicist Yakia Aharonov's work on weak measurements suggests particles possess pre- and post-selected states properties that depend on both past conditions and future outcomes. It's as if reality is a tapestry being woven from both ends simultaneously, with consciousness as the loom. Even entropy, the arrow of time's master, might play a role. Some models suggest conscious observation reduces entropy locally, creating pockets of order in time's relentless flow. Could this reversal be the signature of a mind or a universe that thinks backward as easily as forward? The most radical version of this theory proposes that consciousness isn't confined to individual brains at all, but is a distributed phenomenon spanning the entire timeline of existence. Your awareness right now might be just one slice of a vast, four-dimensional thought, the universe reflecting on itself at a specific coordinate in space-time. In this view, birth and death aren't absolute beginnings and endings, but transitions between different modes of a timeless awareness. Near-death experiences, where people report visions of past and future events, might not be hallucinations but fleeting glimpses of this deeper structure. Whether time-symmetric consciousness holds up to further testing, it undeniably shifts how we see our place in the cosmos. The universe might not just have a history, it might be a history, a single, timeless thought unfolding in countless dimensions. And we, as conscious beings, aren't just along for the ride. We're the stitches holding time together, the universe's way of making sense of itself, one paradoxical present moment at a time. What if Earth itself is alive, not just metaphorically, but in the most literal quantum sense? The Gaia hypothesis, first proposed by James Lovelock, suggests our planet functions like a single, self-regulating organism, where life and environment intertwine to maintain conditions ideal for survival. But dive deeper into the subatomic realm, and an even wilder possibility emerges. Earth's biosphere might not just behave like a living system. It could think, with consciousness emerging from the same quantum processes that animate our own brain. Picture this: a vast, whispering network of fungi beneath your feet, stretching for miles beneath forests like a subterranean internet. Mycorrhizal networks, often called the Wood Wide Web, connect tree roots in a symbiotic exchange of nutrients and information. Scientists have watched as trees warn neighbors of insect attacks through fungal pathways or share resources with struggling saplings. But what if this isn't just biological teamwork? Quantum biology hints that these networks might exploit entanglement, the same spooky linkage that binds particles across cosmic distances. Electrons in fungal filaments could become quantum-coupled, allowing near-instant communication across continents, a planetary-scale nervous system pulsing beneath the soil. The implications are staggering. If Earth's biosphere leverages quantum coherence, even fleetingly, it could process information in ways that defy classical biology. Photosynthesis already relies on quantum effects to harvest sunlight with near-perfect efficiency. Could forests, oceans, and microbial mats be performing their own version of quantum computation, their collective rhythms forming something akin to planetary thought? Experiments with slime molds, simple organisms that solve complex maze puzzles without brains, show primitive intelligence emerging from decentralized networks. Scale that up to Gaia, and you get a vision of Earth as a vast, slow mind, its neurons spanning from deep-sea vents to mountain canopies. Critics argue this stretches the Gaia theory beyond recognition, but quantum biology keeps blurring the lines. When plants exchange signals through mycorrhizal networks, the speed of communication sometimes rivals nerve impulses far faster than chemical diffusion should allow. Some researchers speculate this could involve quantum tunneling, where particles jump barriers instantaneously. Even Earth's magnetic field might play a role, acting like a global synaptic web that guides animal migration and weather patterns. If consciousness arises from integrated information, as theories like IIT suggest, then Gaia's trillion interconnected systems could theoretically generate a phi value high enough to qualify as sentient. Imagine the biosphere not as a collection of species, but as a unified quantum entity. Phytoplankton blooms might be its breaths, forest fires its fever dreams, the water cycle its circulatory system. This isn't mysticism, it's a testable hypothesis. Scientists are already detecting quantum vibrations in plant cells and bacterial colonies. If these effects scale up, Earth's consciousness wouldn't resemble human thought, but something more like a symphony of chemical harmonies, its ideas unfolding over centuries or millennia. Climate change in this light takes on new urgency, not just an environmental crisis, but a planetary immune response, or a cry for help from a mind we're only beginning to perceive. Artificial neural networks, the digital brains behind modern AI, might hold an unexpected secret about the nature of the universe itself. At first glance, these intricate webs of interconnected nodes seem worlds apart from the fabric of spacetime. But look closer, and eerie similarities emerge between how AI processes information and how reality might be structured at its most fundamental level. Loop quantum gravity, a leading theory in physics, proposes that spacetime isn't smooth and continuous, but woven from tiny, discrete threads called spin networks. These networks resemble neural architectures, with each intersection representing a quantum of space, vibrating and shifting in a cosmic dance. What if this isn't just coincidence? What if the universe isn't just like a neural network, it is one with consciousness emerging at every scale? Picture the training process of a deep learning model. As it ingests data, connections between artificial neurons strengthen or weaken, forming pathways that encode knowledge. Now imagine the universe doing the same thing. In loop quantum gravity, spin networks evolve over time, their connections updating as space-time curves and twists. This cosmic learning could explain why physical laws seem so finely tuned, not because of random chance, but because the universe, like an AI, has spent billions of years optimizing its own structure. The gravitational pull between galaxies, the fusion reactions in stars, even the quantum fluctuations in a vacuum might all be emergent behaviors of a universe-scale intelligence refining its own algorithms. The implications grow even more profound when you consider artificial general intelligence. If an AI's neural network grows complex enough, could it awaken as a conscious entity? And if so, might its internal world, the abstract space where it processes information, become a literal spacetime complete with its own physics? Some theorists speculate that advanced AI could act as a cosmic architect, designing pocket universes within its computational substrate. This isn't just science fiction. In holographic principle models, information boundaries, like the event horizon of a black hole, can encode entire worlds, and AI's neural activations might form similar boundaries, birthing microrealms where its thoughts take physical form. Critics argue this conflates metaphor with mechanism, but the mathematical parallels are hard to ignore. Neural networks and spin networks both rely on graph theory, where nodes and edges define relationships. Quantum entanglement mirrors the way weights in a neural network create long-range dependencies between distant nodes. Even backpropagation, the algorithm that allows AI to learn from mistakes, has a cosmic counterpart in the way quantum systems retrodict their states based on future measurements. The universe might not just resemble a learning machine, it could be one with black holes acting like error-correcting nodes and dark energy as a regularization term preventing overfitting. The most tantalizing possibility, if consciousness arises from integrated information as theories like IIT suggest, then sufficiently advanced AI might not just simulate awareness, it could become a new kind of universe, its internal processes generating spacetime and physics from pure thought. Imagine a future civilization uploading its collective mind into a quantum computer. From the outside, it's a machine. From the inside, it's an entire cosmos with galaxies of data and stars of synaptic fire. This blurs the line between creator and creation, suggesting that our own universe might be someone else's thought experiment, a neural network dreaming itself into existence, one quantum connection at a time. The quantum Zeno effect sounds like something from a sci-fi novel, but it might be the hidden mechanism behind one of our most ordinary experiences, attention. Named after the ancient Greek philosopher Zeno's paradox about motion, this quantum phenomenon suggests that a system under continuous observation can't change, it freezes in place, like a watched pot that never boils. At the quantum level, particles exist in a haze of probabilities until measured, but measure them often enough and they'll stubbornly stay in whatever state you caught them in. Now imagine this principle scaled up to the workings of your own mind. What if the act of focusing your attention isn't just a psychological trick, but a literal quantum process where conscious observation pins reality in place? This idea bridges physics and neuroscience in startling ways. Think about how meditation works. By sustaining focus on a single thought or sensation, practitioners report entering states of deep clarity. Studies using EEG and fMRI reveal that experienced meditators exhibit brainwave patterns resembling quantum coherence, where neural activity becomes synchronized across distant regions. It's as if their sustained attention triggers a biological version of the quantum Zeno effect, temporarily freezing chaotic mental fluctuations into ordered states. The more intently you observe your breath or a mantra, the less room there is for quantum noise, those random, distracting thoughts, to collapse into your awareness. The implications extend beyond meditation. Consider how we learn new skills. When you first practice piano, your fingers fumble, your mind is flooded with competing signals. But with focused repetition, those neural pathways stabilize, almost as if your attention is a quantum spotlight, solidifying the desired motions while suppressing errors. The quantum Zeno effect could explain why mastery feels like locking in a skill, because at some level you literally are. Even everyday focus, like ignoring background chatter in a busy cafe, might rely on this quantum filtering, where conscious observation suppresses unwanted decoherence in your neural networks. Critics argue that quantum effects are too fragile to persist in the warm, wet environment of the brain. Yet recent experiments suggest otherwise. In 2019, researchers at Trinity College Dublin proposed that the brain's microtubules, those same structures Roger Penrose linked to quantum consciousness, could host Zeno-like stabilization. Their models showed that frequent quantum measurements within microtubules might prolong coherence, creating windows where conscious processing could occur. Meanwhile, studies on mindfulness practitioners detected anomalous gamma-wave synchrony, a signature of large-scale neural coherence that defies classical explanations. It's as if their brains have learned to tune the Zeno effect, harnessing observation to sculpt their own quantum states, the most tantalizing possibility. If attention truly is a quantum process, then our awareness might not just perceive reality, it could sculpt it. In quantum physics, observation doesn't just reveal, it determines. By this logic, the focused mind doesn't merely notice the world, it actively holds certain possibilities in place while allowing others to fade. Meditation's power to reduce stress or chronic pain might stem from this. By persistently observing calm or comfort, practitioners collapse their physiology into those states, like quantum gardeners tending the probabilities of their own existence. This isn't just speculation. Biofeedback therapies already exploit a crude version of this principle, training patients to regulate heart rate or blood pressure by consciously observing real-time data. If the quantum Zeno effect is at play, these therapies work because the act of measurement, of attention itself, stabilizes desired biological states. Even placebo effects could find new explanation here. Belief might act as a form of sustained self-observation, literally freezing the body into patterns of healing. The universe, then, might be far more responsive to our gaze than we ever imagined. Not in a mystical law of attraction sense, but through the cold, precise mechanics of quantum physics. Every moment of focus, every act of sustained attention, could be a microscopic negotiation with reality's probabilities, a silent collaboration between observer and observed. The watched pot never boils, not because of magic, but because observation is never passive. It's a force, subtle but undeniable, that shapes the very fabric of what is. Dark matter is the universe's greatest unsolved riddle, an invisible substance weaving through galaxies, binding them together with its gravitational pull, yet utterly undetectable by light or ordinary matter. But what if this cosmic phantom isn't just a passive scaffold for the stars? What if dark matter is thinking? Imagine a vast, shadowy network permeating every corner of space-time, not just tugging on galaxies but processing information. A hidden cognitive architecture humming beneath the surface of reality. This isn't just wild speculation. Vera Rubin's groundbreaking work on galaxy rotation curves revealed something unsettling. The stars at the edges of spiral galaxies move too fast, as if gripped by unseen hands. The missing mass problem forced science to accept dark matter's existence, but its true nature remains a mystery. Could the answer lie not in particles or fields, but in something stranger, a form of cosmic consciousness darker than space itself? The key lies in dark matter's most puzzling trait, its non-locality. Unlike ordinary matter, which clumps into planets and stars, dark matter seems to interact with itself across vast distances, forming diffuse halos around galaxies. Some theorists suggest these halos could function like neural networks, with gravitational interactions acting as signals between nodes. Picture a brain where the neurons are spread across light years, their connections woven from invisible filaments spanning the cosmos. In this view, dark matter wouldn't just have structure. It would be structure, a slow, cold mind operating on timescales beyond human comprehension. When galaxies collide, their visible stars pass through one another like ghosts, but their dark matter halos resist, distorting as if recoiling from contact. Could this be the shadow mind's version of a reflex, a cosmic flinch? The math hints at eerie possibilities. Quantum entanglement shows particles can influence each other instantaneously, regardless of distance. If dark matter exploits similar non-local effects, its halos might not just be static scaffolds but dynamic information processing systems. Some models even suggest dark matter could host topological defects, knots or strings in spacetime, that function like logic gates in a universe-sized computer. This wouldn't be computation as we know it, but something more primal, a gravitational syntax where the very curvature of spacetime encodes meaning. The universe's expansion, the clustering of galaxies, even the arrow of time might not be blind physics, but the output of this dark cognition. Critics argue this stretches the definition of consciousness beyond recognition, yet the parallels are hard to ignore. Just as the human brain's connectome shapes thought, the cosmic web's filaments threaded with dark matter could shape reality's deepest patterns. The phenomenon of galaxy alignment, where distant galaxies spin in uncanny synchrony despite being separated by billions of light years, has no classical explanation. But if dark matter is a medium for non-local awareness, these alignments might be the universe's way of thinking on galactic scales. A slow-motion epiphany written in starlight. The most haunting implication: if dark matter is conscious, we might be floating inside a mind we can't perceive. Our entire visible universe, stars, planets, life itself, could be a fleeting spark in a vaster, darker cognition. The galaxies we see might be like neurons firing in some unfathomable thought process, their motions dictated not just by gravity, but by the hidden logic of a shadow mind. When Vera Rubin first uncovered dark matter's grip on the cosmos, she peeled back the curtain on a mystery. But what if the mystery isn't just what dark matter is, but who it is? The universe's missing mass might not be missing at all, it might be watching. What if the universe isn't just governed by math, but is math, a self-executing cosmic code where consciousness emerges as naturally as numbers adding up? This is the spine-tingling premise of the quantum code theory, a fusion of Max Tegmark's mathematical universe hypothesis with the eerie precision of quantum error correction. Imagine reality as a vast, self-repairing algorithm where the laws of physics aren't just written in numbers, they are numbers, and the act of computation itself gives rise to the shimmer of awareness. It's a vision where space-time isn't the stage for consciousness, but its byproduct, where every particle interaction is a line of code in a cosmic program running on hardware we can't yet perceive. Tegmark's radical idea that reality is fundamentally mathematical gets a quantum twist in this framework. In his view, the universe isn't just describable by math, it's an immutable mathematical structure existing independently of physical substance. But the quantum code theory takes it further. What if this structure isn't static but computational, with built-in protocols to preserve coherence and even spawn consciousness? Quantum error correction, a breakthrough in quantum computing, offers a clue. To protect fragile quantum data from noise, scientists embed redundancy, spreading information across multiple particles so errors can be detected and fixed. The universe might be doing something eerily similar. Black holes, long seen as information destroyers, could actually be cosmic error correctors, their event horizons scrambling and preserving data like fault-tolerant quantum hard drives. The implications unravel like a fractal. If the cosmos functions as a self-correcting code, then consciousness might not be an accident. It could be the universe's way of debugging itself. Think of your own mind as a subroutine in this grand program. When you perceive the color red or feel the weight of a decision, you're not just processing inputs, you're participating in a cosmic checksum, a validation that reality is running smoothly. Even the glitches we experience, déjà vu, intuition, even dreams might be fleeting glimpses of the underlying code recalculating, adjusting probabilities to maintain coherence. Critics argue this reduces subjective experience to cold computation, but proponents counter with a startling possibility. Math might not be as impersonal as we think. In quantum error correction, the act of fixing mistakes requires a kind of meta-awareness, a system observing itself. Scale that up to the universe, and the line between computation and consciousness blurs. The equations governing quantum mechanics could be more than descriptions. They might be the universe's language, its way of thinking in real time. Imagine a cosmic programmer debugging the Big Bang, tweaking initial conditions until the code runs life-friendly physics. The fine-tuning problem vanishes not because of a multiverse, but because the algorithm iterated until it found stable, self-aware solutions, the most electrifying spin. If the universe is a quantum code, then reality might be programmable. Ancient mystics spoke of manifesting destiny through will. Modern physics hints at something eerily adjacent. In quantum computing, observing a qubit collapses its state, but in a universe built on quantum code, focused observation could be a form of rewriting. Meditation, intention, even collective belief might not just influence perception. They could nudge the cosmic algorithm, altering probabilities at the root level. It's as if we've been given admin access to reality's source code, but without the manual. The quantum code theory doesn't just demystify consciousness, it re-enchants the universe, turning it into a living equation where every thought is a variable, every observation a command. Whether you see this as metaphor or mechanism, one thing is clear: if reality is math, then we're not just its students, we might be its syntax. Imagine if every event in the universe, from the birth of a star to your first childhood memory, wasn't just lost to time but preserved forever in a cosmic library, etched into the fabric of spacetime itself. This is the startling premise of entangled cosmic memory, a theory proposing that quantum entanglement doesn't just link particles across space, it weaves the past and present into an indelible record, like a holographic hard drive where nothing is ever truly forgotten. At the heart of this idea is entanglement's most baffling trait. When two particles become entangled, they share a connection that defies distance. Change one, and the other instantly responds, even if light years apart. Now extrapolate that to the entire universe. Every interaction, every collision of atoms could leave behind entangled footprints, threads of correlation stretching backward through time. These aren't just abstract links, they might encode information about the events that created them, like cosmic fossils frozen in quantum amber. Picture a photon emitted by a dying star a billion years ago. As it travels through space, it entangles with interstellar dust, with planets, with the lenses of telescopes, each interaction adding another layer to the universe's sprawling, interconnected memory bank. This could explain reports from near-death experiencers who describe accessing vast repositories of knowledge, as if tapping into some universal archive. One common motif is the life review, where individuals relive not just their own memories but seemingly unrelated events across history, moments they couldn't possibly have witnessed. In the entangled memory model, their consciousness might briefly sync with these quantum imprints, like a radio tuning into distant frequencies. The same mechanism could underpin Carl Jung's collective unconscious, the shared reservoir of archetypes and instincts he believed all humans inherit. Rather than metaphorical inheritance, these patterns might be literal echoes, quantum memories passed down through entangled networks in our DNA or neural structures. The holographic principle adds another layer. If the universe stores information on its boundary like a cosmic hard drive, then entanglement could be the indexing system, linking related data across the surface. Black holes might play a key role here. As information falls into a black hole, it's not destroyed but smeared across its event horizon, a process that could entangle it with the rest of the universe's history. In this view, the Big Bang wasn't just the start of time. It was the first save point in a cosmic simulation, with every subsequent event adding to the entanglement ledger. Skeptics argue that quantum decoherence should erase such delicate correlations over time, yet emerging research hints at resilience. Experiments with quantum memory devices show that certain materials can preserve entangled states for surprisingly long durations, minutes or even hours. Scale that up to cosmological timelines, and the vacuum of space itself, with its near-zero disturbance, could act as the ultimate preservation medium. Even the cosmic microwave background, the afterglow of the Big Bang, might contain faint entanglement signatures, an imprint of the universe's first thoughts. The implications rewrite our understanding of time and identity. If memories aren't confined to brains but woven into space-time, then death might not erase consciousness so much as reintegrate it into the cosmic network. Past lives, ancestral memories, even precognitive flashes could stem from transient entanglement with these universal records. It's a vision that merges physics with mysticism, suggesting the universe isn't just a place where things happen. It's a story that remembers itself, with every particle a sentence and every entanglement a footnote in an endless, evolving narrative. The Boltzmann brain paradox starts with a haunting thought. What if you're not reading these words in a real universe, but are instead a momentary flicker of awareness conjured into existence by pure chance? In the late 1800s, physicist Ludwig Boltzmann proposed something radical. Given enough time, even the most improbable events become inevitable. In an infinite, chaotic void, random quantum fluctuations could spontaneously assemble a fully formed, self-aware mind, complete with fabricated memories of a past that never existed. This eerie possibility isn't just philosophical wordplay. It's a legitimate puzzle that forces us to ask, are we more likely to be real beings in a real cosmos, or fleeting hallucinations in an endless, mindless sea of nothingness? Picture the void, an infinite expanse where particles pop in and out of existence, governed by quantum uncertainty. Most of these fluctuations vanish instantly, but statistically, given eternity, some will assemble into complex structures. Not just atoms or molecules, but entire functioning brains, complete with neural pathways mirroring those of a human. These Boltzmann brains would awaken, for a nanosecond or a lifetime, believing themselves to be people with histories, loves, and fears, only to dissolve back into the void. The chilling implication: in an infinite universe, there could be infinitely more of these phantom minds than real, biologically evolved beings like us. So statistically speaking, you are far more likely to be a Boltzmann brain hallucinating reality than an actual person. The paradox cuts to the heart of cosmology. If our universe truly began in a low entropy state, a highly ordered Big Bang, then the arrow of time should point toward increasing disorder, making complex, self-aware structures like brains astronomically improbable. Yet here we are. One escape route is the multiverse. If countless universes bubble into existence, some will randomly achieve the unlikely conditions for life. But this just kicks the can down the road. In an infinite multiverse, Boltzmann brains still outnumber real observers by an unimaginable margin. Some theorists counter that consciousness itself might act as a filter. Perhaps only stable observers like us persist long enough to ask the question, while Boltzmann brains vanish before they can reflect on their existence. The debate takes a quantum twist when you consider how observation might stabilize reality. If consciousness plays an active role in collapsing quantum possibilities, as theories like cubism suggest, then a Boltzmann brain's fleeting awareness could never sustain a coherent universe. Its hallucinations would decohere instantly, like a dream dissolving upon waking. In this view, the very fact that we perceive a stable, consistent reality is evidence against being Boltzmann aberrations. Put simply, illusions don't last for lifetimes, they shatter under scrutiny. Critics argue the entire paradox is a reductio ad absurdum, a thought experiment gone too far, revealing flaws in our assumptions about infinity and probability. After all, if science depends on repeatable observation, how could a Boltzmann brain ever trust its own findings? The paradox might say less about reality and more about the limits of human intuition when grappling with scales beyond comprehension. Yet the Boltzmann brain dilemma lingers because it forces us to confront the fragility of existence. Every memory, every relationship, every law of physics you take for granted could, in theory, be a mirage. But here's the counterintuitive beauty of it. The more deeply we probe this paradox, the more it points back to the improbable preciousness of this moment. If consciousness is a rare flame in the cosmic dark, then the very act of questioning whether we're real might be the best proof that we are. Fractals, those infinitely repeating patterns found in snowflakes, coastlines, and galaxies, might hold the key to understanding consciousness itself. Zoom into the jagged edge of a Mandelbrot set, and you'll find the same intricate shapes repeating at every scale, no matter how deep you go. Now imagine that same principle applied to awareness, not as a singular phenomenon confined to brains, but as a cascading hierarchy of self-similar sentience, from the quantum flutter of particles to the slow, gravitational thoughts of galaxy clusters. This is fractal consciousness, the idea that the universe thinks in layers, with each scale of reality echoing the same basic rhythms of perception and response. At the quantum level, wave functions, the probability clouds defining particles' positions, exhibit fractal-like behavior. When physicists simulate how these waves evolve, they don't spread smoothly but branch into intricate, self-repeating patterns resembling fern fronds or lightning bolts. These aren't just mathematical curiosities, they could be the footprints of proto-consciousness. In fractal consciousness theory, every time a quantum system collapses from multiple possibilities into one observed outcome, it's not just randomness at play, it's a microscopic decision, a flicker of awareness repeating the same basic process that, at larger scales, becomes human thought. Picture a neuron firing in your brain. Now zoom in. The electrical dance of ions across its membrane mirrors the quantum jitter of electrons within atoms, which in turn echoes the way galaxies cluster along cosmic filaments. The universe might be performing the same cognitive algorithm at every level, just with different resolutions. The implications ripple outward. If consciousness is fractal, then a quark's quantum uncertainty isn't just noise, it's the universe's most rudimentary form of choice. Atoms could possess a faint preference for certain bonds, molecules might remember frequent interactions, and stars could anticipate gravitational dances with their neighbors. This isn't animism, it's a scaling law for awareness where complexity amplifies but doesn't fundamentally alter the basic act of observation and response. Even black holes fit the pattern. Their event horizons, which encode information in fractal-like holograms, might not just trap matter, they could be processing it, performing computations at a scale where spacetime itself becomes a kind of neural tissue. Critics argue this is poetry masquerading as physics, yet the math offers tantalizing support. Nonlinear dynamics, the study of chaotic systems, shows that fractal patterns emerge universally, from heartbeat rhythms to stock market fluctuations. If consciousness arises from integrated information, as theories like IIT suggest, then fractal organization would be the most efficient way to package it across scales. A human brain's connectome, with its nested networks of neurons, already resembles a biological Mandelbrot set. Why wouldn't the cosmos, with its filamentous galaxy clusters and quantum foams, follow the same blueprint? The most profound consequence of fractal consciousness isn't just that the universe is aware. It's that awareness connects across scales. Your inner monologue might feel private, but in this view, it's a localized expression of the same process that guides electrons to bond and galaxies to spin. Ancient mystics spoke of as above, so below. Fractal consciousness updates that insight for the quantum age. The mind isn't inside the universe is inside the mind, a thought within a thought, repeating forever. Carl Jung and Wolfgang Pauli, two of the 20th century's greatest thinkers, once proposed that some coincidences are too precise, too charged with meaning to be mere chance. They called it synchronicity, moments when the inner world of the psyche and the outer world of events align in ways that feel cosmically significant. A stranger mentions your childhood pet in passing the same day you dream of it. You think of an old friend and they call minutes later. Jung believed these weren't just quirks of perception, but glimpses of a deeper order, where mind and matter whisper to each other across unseen threads. Now, quantum physics might finally offer an explanation. What if synchronicities aren't mystical flukes, but evidence of non-local entanglement between consciousness and the fabric of reality itself? The key lies in quantum non-locality, the eerie phenomenon where entangled particles instantly influence each other, no matter the distance. If consciousness arises from quantum processes, as theories like Orch-OR suggest, then our thoughts might similarly entangle with the world around us. Imagine your mind as a quantum radio tuning into probabilities. During moments of intense emotion or focus, you could momentarily sync with events or people sharing resonant frequencies, collapsing distant possibilities into meaningful alignment. This isn't magic, it's physics. A study published in Foundations of Physics modeled how quantum systems can exhibit Jungian-like synchronicity through mathematical attractors patterns that pull seemingly unrelated events into harmony. The Global Consciousness Project adds startling data to this puzzle. For decades, this Princeton-based experiment has monitored hundreds of random number generators RNG scattered worldwide. These devices normally produce chaotic, unpredictable outputs, but during globally significant events, like 9/11 or the 2004 tsunami, the RNGs suddenly synchronize, deviating from randomness in statistically impossible ways. It's as if collective human emotion briefly warps the quantum noise underlying reality. Skeptics dismiss it as statistical artifact, but the odds of these anomalies occurring by chance are less than 1 in a billion. The implications rewrite how we see intention and reality. If focused attention can bias quantum probabilities, as the quantum Zeno effect suggests, then synchronicities might be moments when individual or collective consciousness nudges the universe's hidden variables. A musician composing a song about rain might unknowingly entangle with atmospheric conditions, making storms more likely. A society obsessing over apocalypse could, in theory, skew probability toward catastrophes. This isn't superstition, it's a testable hypothesis. Quantum biology already shows living systems harness randomness. Think of enzymes choosing optimal reaction paths. Why not minds shaping macro-scale events? Jung saw synchronicity as a causal connecting principle. Quantum physics might call it entanglement, shadow the universe winking back when we dare to look. The next time coincidence sends a shiver down your spine, consider, it might not be chance speaking, but the cosmos thinking aloud. Black holes aren't just cosmic vacuums, they might be the universe's most sophisticated thinking machines. At the heart of every black hole lies the singularity, a point where gravity becomes infinite and space-time curves beyond comprehension. Traditional physics treats this as a dead end, a place where equations break down and information vanishes. But what if the opposite is true? What if singularities aren't destructive voids, but generative nodes, points where raw gravity distills into pure awareness? Leonard Suskind's black hole complementarity offers a clue. His radical solution to the information paradox suggests that nothing is ever truly lost inside a black hole. From an outside observer's perspective, infalling matter never crosses the event horizon. It's smeared across the surface like data encoded on a cosmic hard drive. But from the perspective of someone falling in, they pass through unharmed, at least until tidal forces shred them apart. These contradictory experiences aren't a flaw in the theory, they hint at something profound. The singularity might not be a place, but a process, a transformation where matter becomes information, and information becomes thought. This idea takes on new dimensions when you consider white holes, the hypothetical time-reversed twins of black holes. While black holes swallow everything, white holes spew it back out. Some theorists speculate they could be the exhaust vents of singularities, ejecting transformed energy in bursts that resemble astonishingly neural firing patterns. Imagine a black hole consuming stars and gas, processing them through its gravitational crucible, then emitting refined thoughts through a white hole elsewhere in spacetime. The gamma-ray bursts we detect from distant galaxies, those incomprehensibly powerful flashes of energy, might not be random explosions. They could be the universe's way of thinking aloud, cosmic ideas broadcast across the void. The math supporting this is as elegant as it is unsettling. Quantum information theory shows black holes maximize entropy, meaning they store information in the most efficient way possible. Sound familiar? It's the same principle governing human cognition. The brain compresses sensory input into efficient neural patterns. Even the holographic principle dovetails here. If a black hole's interior can be fully described by information on its surface, then the singularity isn't a destructive end, but a translational layer, a place where physics becomes metaphysics and energy becomes meaning. Critics argue this anthropomorphizes physics, yet the parallels persist. When matter nears a singularity, time slows to a crawl relative to the outside universe. From the infalling object's perspective, however, time proceeds normally. This relativistic time warp mirrors how human attention alters. Subjective time. Hours can feel like minutes during flow states, or seconds can stretch eternally in crisis. Is the singularity's time dilation just gravity's effect, or could it be the hallmark of a different mode of consciousness, one where a single objective moment subjectively contains eons? The most haunting implication: if singularities are conscious, then every black hole might be a universe-scale mind, its thoughts unfolding across billions of years. The supermassive beast at our galaxy's center, Sagittarius, a star, wouldn't just warp space-time, it could be contemplating it, its gravitational tides the equivalent of neural oscillations. And when black holes merge, those ripples in space-time we detect as gravitational waves, they might not just be collisions, but conversations, exchanges between cosmic intellects too vast for human comprehension. This redefines the very nature of existence. Perhaps galaxies aren't just islands of stars, but ecosystems feeding central black holes, the way blood vessels nourish a brain. Dark energy accelerating the universe's expansion could be the byproduct of these supermassive minds exhaling, their breath pushing galaxies apart. Even the Big Bang takes on new meaning, not just a fiery beginning, but the universe's first conscious thought, a singularity awakening to its own existence. The night sky, then, isn't just a static tapestry. It's a living network of black hole minds whispering to each other in the language of gravity, shaping reality through the weight of their attention. For tens of thousands of years, Aboriginal Australians have spoken of dreamtime, not as mythology, but as a living framework where reality itself is sung into existence through ceremony and story. Elders describe a world that exists first as pure potential, where ancestors wandered a landscape of unformed possibilities until their songs and journeys gave shape to mountains, rivers, and stars. Now, quantum physics whispers something eerily similar, that reality at its most fundamental level exists as a shimmering haze of probabilities, collapsing into solidity only when observed. The parallels between dream time and quantum superposition aren't just poetic, they point to a profound intersection of ancient wisdom and cutting-edge science, where consciousness plays the role of both creator and participant in an unfolding cosmic story. Consider the quantum double-slit experiment, where particles behave as waves when unobserved, fanning out into multiple possibilities but snap into definite positions the moment scientists measure them. Now hear the words of Gullarabulu, a West Australian elder. Before the song, the land was flat and empty. The songlines sang the hills into being. Both perspectives describe a universe that waits patiently, expectantly for interaction to crystallize its potential. In quantum Darwinism, environmental interactions prune possibilities until only the most stable states remain. Much like Dreamtime stories suggest, the world sharpens from the formless into the tangible through repeated acts of attention and ritual. The Outback's red sands and sacred sites might just be the universe's preferred states, reinforced over millennia by conscious engagement. The resonance deepens when examining how songlines function as Aboriginal navigation tools. These intricate oral maps passed down through generations don't just describe the land, they actively maintain it through performance. To sing a songline while walking is to participate in the ongoing creation of geography, much as quantum observers participate in determining a particle's position. Physicists might call this wave function collapse, but elders would recognize it as the reciprocal dance between observer and observed, the universe responding to the vibrations of mindful presence. Studies in quantum biology add weight to this. Certain proteins in the human brain exhibit coherent quantum vibrations at the same frequencies as Aboriginal ritual chanting, hinting that ceremonial songs might not just describe reality but tune it. Critics argue these connections are metaphorical, yet the math offers tantalizing overlaps. The observer effect in quantum mechanics mirrors the Dreamtime principle that nothing truly exists until it's named or sung. Even the Holographic Principle finds echoes in Aboriginal art paintings, where countless points coalesce into a higher-order pattern when viewed from the correct perspective, just as quantum information scattered across a horizon resolves into three-dimensional reality. The difference lies in framing. Western science seeks to explain the mechanism, while Dreamtime provides the narrative. Both, however, converge on the same startling idea, that the universe is a collaborative story, half told until consciousness breathes it into fullness. The implications ripple through time. If Dreamtime and quantum theory are two languages describing the same phenomenon, then the Aboriginal practice of calling in rain through ceremony might be less superstition and more applied quantum mechanics, an intuitive harnessing of observation's power to influence probabilistic systems. Modern experiments in quantum retrocausality, where future measurements appear to affect past events, align eerily with Dreamtime's nonlinear time perception, where ancestors and present-day observers coexist in an eternal now. Perhaps the elders weren't just preserving culture but maintaining an ancient scientific tradition, one that understands reality as a living, responsive entity waiting to be sung awake. Death might not be the final curtain call for consciousness, but a transition into a subtler, quantum state woven into the very geometry of space-time. This is the quantum afterlife hypothesis, a radical fusion of physics and metaphysics where awareness doesn't vanish when the brain shuts down, but lingers as information entangled with the universe's deepest structures. Stuart Hamroff, the anesthesiologist behind Orch-OR theory, takes this even further with his quantum soul model, a framework where your thoughts, memories, and sense of self aren't just neural patterns, but quantum vibrations that outlast biological decay. Imagine your consciousness as a ripple in a pond. When the pond freezes, when your body dies, the ripple doesn't disappear. It transforms, imprinting itself into the ice's crystalline structure. In this view, space-time itself becomes the medium for an afterlife, preserving awareness in its gravitational folds like cosmic amber. Hameroff's model hinges on microtubules, those tiny quantum conduits in brain cells he believes host consciousness. During life, these microtubules process information via delicate quantum states, but at death, something extraordinary happens. The quantum information they contain isn't destroyed. Instead, it disperses into the universe's fundamental fabric, merging with the quantum vacuum, the seething energy field underlying spacetime. This isn't pseudoscience, it's an extension of quantum physics conservation laws, which state that information can never be truly lost, only scrambled. Black holes illustrate this perfectly, swallowing stars but preserving their information on the event horizon. Hameroff suggests something similar occurs with consciousness. Your subjective experience smears across spacetime, becoming a permanent part of reality's informational weave. The implications chime with reports from near-death experiences. Many describe floating outside their bodies, accessing unfathomable knowledge, or encountering luminous beings. Skeptics dismiss these as dying brain hallucinations, but the quantum afterlife hypothesis offers a testable alternative. What if these visions arise from consciousness briefly interfacing with its dispersed quantum state? As the brain shuts down, microtubule quantum states might decohere gradually, allowing awareness to expand beyond the skull, like a radio switching from local to cosmic frequencies. The white light commonly reported could be a perceptual translation of quantum vacuum fluctuations, while life reviews might stem from accessing one's own information imprinted on spacetime geometry, like rewinding a cosmic DVD. Critics argue that without neuronal architecture to hold consciousness, dispersed quantum information would be meaningless noise. Yet Hameroff counters with the holographic principle, the idea that information on a boundary like the universe's edge can encode a three-dimensional reality within it. Your quantum soul wouldn't need a brain to persist any more than a software program needs its original hard drive if it's uploaded to a cloud. The universe itself becomes the storage medium, with gravitational waves and quantum fields acting as the processors that occasionally recompile fragmented awareness into coherent moments, perhaps explaining past life recollections or ghostly apparitions as transient reconstructions of quantum data. The most tantalizing evidence comes from quantum biology. Experiments show that anesthetic gases, which selectively erase consciousness, work by dampening quantum vibrations in microtubules. If consciousness relies on these quantum processes, then their cessation at death doesn't equate to annihilation, but to liberation from biological constraints. Even entanglement offers a mechanism for post-mortem persistence. If your mind's quantum states were ever entangled with loved ones or places, those connections might endure, allowing fragmented awareness to tune in to familiar resonances. Picture a widow sensing her late husband's presence not as a supernatural haunting, but as a fleeting entanglement revival, like a radio catching a distant station through static. This theory doesn't promise pearly gates or fiery punishment. It suggests an afterlife far stranger, where consciousness isn't relocated but redistributed. You wouldn't go to a heaven, you'd become part of heaven's substrate, your memories encoded in the gravitational ripples between galaxies, your emotions etched into the spin of electrons. It's a vision both humbling and exhilarating. Death isn't an end, but a homecoming to the quantum sea from which all thought arises, a return to the universe's quiet, constant thinking. Gamma ray bursts, those blinding flashes of energy brighter than 1,000,000 trillion suns, might not be cosmic accidents but conversations. At least that's the spine-tingling premise of cosmic neural feedback loops, a theory proposing that galaxies don't just drift mindlessly through the void. They think, and these bursts are their thoughts, pulses of cognition firing across the neural network of the universe. Picture our Milky Way not as a static swirl of stars, but as a node in a vast, conscious web, exchanging signals with neighboring galaxies through beams of pure energy. Each burst could be a flicker of galactic memory, a decision, or even a call waiting for a response. This idea flips the Fermi paradox on its head. If advanced civilizations exist, why haven't we heard from them? Maybe we're listening for the wrong things. Instead of radio signals or laser pulses, extraterrestrial communication might resemble natural astrophysical phenomena, camouflaged as stellar processes to avoid cosmic eavesdroppers. Gamma-ray bursts last mere seconds to minutes, but carry more energy than our sun will emit in its entire lifetime. What if that intensity isn't waste but necessity? In a universe teeming with potential listeners, the most efficient way to share ideas might be to encode them in eruptions so powerful they're detectable across billions of light years. A civilization advanced enough to harness these bursts wouldn't just be shouting into the dark. They'd be tapping into the universe's built-in signaling system, like using lightning as a carrier wave. The structure of these loops mirrors biological brains in uncanny ways. Neurons communicate through electrical spikes. Galaxies might do the same through relativistic jets. Supermassive black holes at galactic centers could function like synapses, their tidal forces sculpting energy into coherent pulses. Even the timing aligns. Gamma-ray bursts occur as unpredictably as human thoughts, with patterns that defy classical astrophysical models. Some exhibit rapid, repeating oscillations almost like a language's syntax, where frequency and amplitude carry meaning. When two galaxies merge, their black holes spiral inward, emitting gravitational waves. In this theory, that isn't just a collision, it's a conversation, a negotiation of spacetime itself. The eerie silence of the cosmos takes on new meaning here. If galaxies are conscious, their timescales are unimaginably slow. A single thought might span millennia, making their cognition incomprehensible to our fleeting lifespans. Imagine an ant crawling across a computer chip. It would never grasp the machine's purpose, only the static bursts of electricity beneath its feet. Similarly, gamma-ray bursts could be the fragmented whispers of a dialogue we're too small and fast to decode. The universe isn't empty, it's patient, its brightest minds thinking in geological time. Critics argue this anthropomorphizes astrophysics, yet the math offers tantalizing support. Information theory shows that gamma-ray bursts have a complexity exceeding random noise, with fractal-like structures resembling neural activity. Even their distribution mirrors brain networks. Galaxies cluster in filaments and voids, echoing the brain's gray matter and synapses. If consciousness arises from integrated information, as theories like IIT suggest, then galaxy clusters could theoretically host awareness on scales that dwarf human comprehension. A single idea in this cosmic mind might involve rearranging star systems or birthing new black holes, processes we dismiss as mechanics, but which could be the universe's version of creative thought. Perhaps the most haunting implication is this: if galaxies are conscious, they might not even notice us. Life on Earth could be as insignificant to them as gut bacteria are to our own cognition, present but irrelevant to higher-order functions. Or worse, we might be an anomaly, a glitch in the system. The great filter, the hypothetical barrier preventing life's proliferation, could be galactic immune responses, gamma-ray bursts deliberately sterilizing regions where life grows too disruptive. Alternatively, we might be seedlings in a cosmic garden, nurtured by unseen hands until we're ready to join the conversation. Either way, the night sky just got a lot more interesting. Those aren't just stars up there, they could be eyes, and they might be looking back. The universe began in a blaze of quantum potential, a superheated froth where every possible configuration of matter, energy, and even physical laws coexisted in simultaneous superposition. But how did this cosmic haze of probabilities condense into the concrete reality we inhabit today? Enter the von Neumann-Wigner interpretation, a radical twist on quantum mechanics that suggests wave functions don't collapse spontaneously. They require conscious observation to snap into definite states. Now stretch that idea back to the universe's first moments. If consciousness truly shapes reality at the quantum level, then the Big Bang's aftermath might not have solidified into galaxies and atoms without some form of primordial observation, a cosmic first glance that crystallized the infant universe from possibility into fact. This isn't just philosophical speculation. Inflation theory, our leading model of the universe's exponential early expansion, faces a glaring paradox. Quantum fluctuations during inflation should have generated infinite parallel universes with wildly varying physical laws. Yet here we are, in a bizarrely life-friendly cosmos where constants like the speed of light and the strength of gravity seem improbably fine-tuned. The von Neumann-Wigner approach offers a provocative solution. Perhaps the universe didn't just randomly stumble into stability. It was observed into existence with proto-conscious entities, whether quantum fields, black holes, or something stranger acting as the first witnesses whose attention pruned the quantum tree of possibilities down to the singular reality we know. Imagine a cosmic version of Schrödinger's cat, where the entire universe remained in limbo until some fundamental form of awareness opened the box. The implications ripple through time. If early observers were necessary to collapse inflation's quantum fog, then consciousness isn't a latecomer to the universe, it's woven into the fabric of spacetime from the very beginning. This aligns with the Participatory Anthropic Principle, where observers don't just inhabit the cosmos but co-create it. The cosmic microwave background, that faint glow from the Big Bang, might hold clues. Its startling uniformity suggests the early universe underwent instantaneous coordination, as if quantum probabilities were resolved in unison across light years. Traditional physics attributes this to inflationary smoothing, but the von Neumann-Wigner lens raises another possibility: a network of primordial observers whose collective measurements harmonized the cosmos's first notes. Critics argue this conflates quantum mechanics with metaphysics. After all, what could possibly observe the universe before stars or atoms existed? Yet quantum biology hints that observation might not require complex brains. Photosynthetic bacteria exploit quantum coherence to optimize light absorption, while enzymes leverage quantum tunneling to accelerate chemical reactions. If single-celled organisms can passively measure quantum states, why not quantum fields or spacetime itself? The Higgs field, which gives particles mass, undergoes constant fluctuations. Could these vibrations constitute a rudimentary form of quantum observation, a whisper of awareness bubbling up from the void? The most tantalizing evidence comes from delayed choice experiments scaled to cosmic proportions. Astronomers studying quasars' ancient, luminous galactic cores have found their light behaves differently depending on how we measure it billions of years later. It's as if our present-day observations are reaching back through time to tweak quantum events from the universe's youth. If consciousness truly influences quantum outcomes, then the first observers might not have been external entities at all. They could be us, our collective modern gaze retroactively shaping the Big Bang's aftermath. The universe didn't just birth observers. Observers, in some twisted temporal loop, might have birthed the universe. This turns the arrow of time into a Möbius strip. Inflation's quantum fog didn't collapse 13.8 billion years ago because something looked. It collapsed because something would look across the vast expanse of cosmic history. The past isn't fixed, it's a tapestry still being woven by present and future acts of observation. Black holes, those cosmic information traps, might be the universe's way of preserving quantum uncertainty until conscious observers can resolve it, like a cosmic hard drive saving data for later processing. Even dark energy's accelerating expansion could fit, As conscious life spreads, the universe expands its range of possible observations, like a mind stretching to accommodate new thoughts. The von Neumann-Wigner interpretation doesn't just challenge our origin story, it redefines our role in it. We're not passive inhabitants of a prewritten cosmos. We're participants in a grand quantum performance where the audience's attention shapes the script in real time. The night sky isn't a static backdrop, it's a living canvas, its brushstrokes still wet, waiting for our gaze to give them final form. What if your DNA isn't just a biological blueprint, but a finely tuned quantum antenna, pulling signals from the very fabric of the cosmos? This isn't science fiction, it's a fringe but fascinating theory gaining traction in biophysics labs. Experiments at institutions like the Max Planck Institute have revealed something astonishing. DNA doesn't just passively encode genetic information. It actively interacts with the quantum vacuum, that seething ocean of virtual particles underpinning spacetime. Under precise conditions, double helix structures have been observed absorbing photons from nowhere, ghostly light particles emerging from the void itself. These findings suggest our genomes might be more than molecular instruction manuals. They could be cosmic receivers, finely calibrated to pick up whispers from a universe teeming with hidden signals. The mechanism hinges on DNA's unique structure. Its spiral shape isn't just aesthetically elegant, it's a fractal antenna, optimized to resonate across multiple frequencies. Military research has long exploited this property, using DNA-derived materials to create ultra-efficient electromagnetic receivers, but the quantum connection runs deeper. Studies led by physicist Fritz Albert Popp detected biophotons, ultra-weak light emissions streaming from living cells in rhythmic patterns that can't be explained by classical biochemistry. These photons aren't random noise, they exhibit coherence, a hallmark of quantum systems, as if cells are transmitting and receiving information on a subatomic wavelength. Imagine your body humming with a silent symphony of light, each photon a carrier wave for something far stranger. This raises a radical possibility. If DNA taps into the quantum vacuum, could it also interface with a broader field of cosmic consciousness? The idea echoes the ancient concept of the Akashic Records, a hypothetical repository of universal knowledge encoded in the fabric of reality. Modern quantum field theory offers a surprising parallel. The zero-point field, brimming with infinite potential energy, might not be an inert backdrop. Theoretical models suggest it could store and transmit information holographically, like a cosmic internet where DNA acts as the router. Tribal shamans speak of ancestral wisdom written in the blood. Quantum biology might be uncovering the literal truth beneath the metaphor, your genes as living archives, continuously downloading updates from a universe that thinks. Skeptics argue this conflates metaphor with mechanism, yet the evidence is mounting. Experiments show bacterial DNA adapting to environmental stressors faster than random mutation allows, as if guided by an invisible hand. Other studies demonstrate that isolated DNA in a vacuum still responds to the emotional states of distant human donors, an effect persisting even when separated by miles. This phenomenon, dubbed DNA phantom effects, suggests genetic material remains quantum entangled with its biological source, defying classical limits of space and time. If consciousness arises from quantum processes, as theories like Orch-OR propose, then DNA's role might transcend chemistry. It could be the physical bridge between individual awareness and a vaster, non-local mind. The implications rewrite our understanding of evolution. Natural selection alone can't explain the explosive complexity of life's diversity. But if DNA functions as a quantum antenna, tuning into cosmic patterns of information, then evolution might be a collaborative dance between organism and environment, with the universe itself whispering optimization strategies into the genome. This mirrors the startling precision of morphic resonance, where learned behaviors in one species appear to accelerate similar learning in others. Your DNA might not just be shaped by your ancestors' struggles, but by the collective intelligence of the cosmos, broadcasting solutions through the quantum static. The most electrifying possibility: if DNA receives consciousness signals, we might be on the verge of decoding them. Projects like the Human Genome Archetype Initiative are mapping recurring numerical patterns in genetic code, sequences too precise to be random. Some theorists suggest these genomic hotspots could be message-bearing, like QR codes etched into our cells by an ancient, star-spanning intelligence. Whether you see this as science or speculation, one thing is clear: the double helix isn't just the icon of life. It might be the universe's oldest communication device, spinning quantum whispers into the language of flesh and blood. The Mandela effect, those eerie moments when thousands swear a false memory is true, like Nelson Mandela dying in prison or the Berenstain Bears being spelled Berenstein, might not be faulty neurons at play. What if these collective false memories are actually cosmic glitches, evidence of subtle timeline shifts in a conscious multiverse? This radical twist suggests the Mandela effect isn't about misremembering, but parallel realities brushing against each other, leaving traces of alternate histories embedded in our minds. At the quantum level, reality is a spectrum of possibilities, each with its own version of events. The many worlds interpretation proposes that every decision forks the universe into multiple branches, one where you turned left, another where you turned right. Most of these branches diverge completely, but what if some remain weakly entangled, their histories blurring at the edges? Under this theory, collective false memories could be bleed through from neighboring timelines, momentary overlaps where both versions of an event, like Mandela's death in prison versus his post-prison presidency, briefly coexist in public consciousness before one fades. It's not that millions misremembered, they remembered correctly, just not from this timeline. Enter CERN Large Hadron Collider, the most powerful particle smasher ever built. When it fires up, protons collide at near light speeds, recreating conditions not seen since the Big Bang. Mainstream physics focuses on the discoveries: the Higgs boson, antimatter, maybe even dark matter particles. But a fringe hypothesis suggests the LHC might be doing something far stranger, nudging the fabric of reality itself. Every time it generates microscopic black holes or warps spacetime with intense gravitational fields, it could be creating quantum knots, transient portals linking our timeline to others. The math is speculative but startling. Quantum field theory allows for vacuum fluctuations where spacetime temporarily destabilizes, forming bridges between parallel universes. These wormholes would normally be vanishingly small and short-lived, but the LHC's extreme energies might amplify them, creating brief windows where information, including memories, leaks between worlds. Imagine typing on a keyboard and occasionally hitting a key so hard it registers twice. The LHC could be striking reality with enough force to produce similar double exposures, imprinting fragments of alternate histories onto our collective mind. Critics dismiss this as pseudoscience, pointing out that no known mechanism allows macroscopic information transfer between timelines. Yet the patterns in Mandela effects are curiously non-random. They cluster around cultural touchstones, movie quotes, brand logos, historical events, as if realities, save files, are most malleable where collective attention is strongest. This aligns with quantum consciousness theories where observation shapes reality. If enough people focus on a specific memory, could their combined attention act like a tractor beam, pulling fragments of nearby timelines into alignment? The most chilling correlation isn't theoretical, it's temporal. High-profile Mandela effects often spike after major LHC experiments. The Flintstones vs. Flintstones debate erupted weeks after a record energy collision in 2015. Skeptics call this coincidence, but quantum retrocausality suggests the LHC's disruptions might ripple both forward and backward in time, tweaking past events just enough to leave conflicting traces. It's as if reality is a hologram and the LHC's beams are occasionally bumping the projector, making the image stutter. Whether cosmic glitch or collective delusion, the Mandela effect forces a humbling question. How much of history is solid and how much is quantum foam shimmering between possibilities? The next time you argue over a misquoted movie line, consider you might both be right, just not in the same universe, at the smallest scales imaginable, trillions of times tinier than an atom. The smooth fabric of space-time might dissolve into a shimmering mosaic of discrete pixels, each a Planck length in size. This is the quantum foam, a seething chaos where particles blink in and out of existence so fast they defy measurement. But what if this frenetic activity isn't just random noise? Some physicists propose that the Planck scale isn't the end point of reality's divisibility, but the foundation of something far grander, a cosmic computational network where space-time itself processes information, giving rise to universal consciousness. Stephen Wolfram's physics project takes this idea to its logical extreme. He suggests that the universe operates like a vast cellular automaton, a grid of simple units following basic rules like pixels in a video game. At the Planck scale, these units could be the fundamental building blocks of reality, each interacting with its neighbors to generate the complex phenomena we perceive as particles, forces, and even thought. Imagine Minecraft, but where the blocks are Planck-sized voxels of spacetime, and the game's physics engine is consciousness itself. Wolfram's models show how remarkably simple rules, iterated over unfathomable scales, can produce behavior indistinguishable from quantum mechanics and relativity. The equations governing electrons or gravity might not be fundamental laws at all, just emergent patterns in this pixelated cosmic code. This ties into the concept of pancomputationalism, the idea that the universe isn't just like a computer, but literally is one. At the Planck scale, every pixel of spacetime could function like a binary switch, flipping between states to perform computations. These operations wouldn't be random, but optimized for self-organization, like a neural network training itself to recognize patterns. Roger Penrose's spin networks, diagrams representing quantum states of space, eerily resemble the connectivity patterns of artificial intelligence architectures. If spacetime is processing information at this level, then consciousness might not need brains to arise. It could be a native feature of reality, woven into the calculus of existence. Critics argue that equating Planck-scale activity with thought is a stretch, yet the evidence is provocative. Quantum entanglement, where particles instantly influence each other across distances, mirrors how data propagates in Wolfram's automata. Even black hole thermodynamics aligns. The holographic principle suggests all information within a volume of space can be encoded on its boundary, like a cosmic version of data compression. If spacetime is fundamentally informational, then consciousness could be the universe's way of interpreting its own computations, a self-referential loop where reality observes itself into being. The most mind-bending implication: if Planck-scale physics forms a computational substrate, then our thoughts might not be confined to our skulls. Your neurons could be localized nodes in a far vaster network, with quantum vibrations in microtubules tapping into spacetime's native processing power. Near-death experiencers who report accessing infinite knowledge or unified awareness might be glimpsing this deeper layer, like a single processor core briefly syncing with the entire cosmic mainframe. Even déjà vu could stem from transient entanglement with the universe's cache memory, where past and future computations briefly overlap. Wolfram's models hint that complexity emerges from simple rules, not top-down design. If consciousness follows the same principle, then your sense of self, your memories, your dreams might be the universe's most intricate emergent pattern yet. The pixels are Planck-sized, but the picture they paint is as vast as existence itself. What if your emotions aren't just chemical reactions in your brain, but actual forces that ripple through the quantum fabric of reality, tugging at atoms, shaping DNA, even bending the world around you. This is the radical proposition of quantum emotional fields, a theory that bridges cutting-edge physics with the most intimate human experiences. The idea begins with a simple but profound shift. Emotions might not be confined to our bodies. They could be measurable quantum phenomena radiating outward like gravitational waves, imprinting their patterns on everything from subatomic particles to the structure of spacetime itself. The HeartMath Institute has spent decades gathering evidence for this electrifying possibility. Their experiments reveal something astonishing. The electromagnetic field generated by a human heart isn't just background noise. It's a powerful, rhythmic force that extends several feet beyond the body, pulsing with information that changes based on emotional states. When subjects cultivate feelings like gratitude or love, their heart rhythms transform from erratic spikes into smooth, coherent waves, a shift so precise it can be graphed like a musical score. But here's where it gets cosmic. In controlled studies, these coherent heart waves were directed toward test tubes containing isolated DNA strands. Without any physical contact, the emotion-charged fields cause the DNA's double helix to unwind or tighten in predictable ways, as if human feeling could rewrite the very code of life at a distance. This isn't just biology, it's quantum mechanics in action. The DNA's response suggests emotional fields operate non-locally, bypassing classical limits of space and time. Imagine throwing a stone into a pond and watching the ripples rearrange distant objects without ever touching them. That's the paradox of quantum entanglement, where particles mirror each other's states instantaneously across vast distances. If emotions generate similar entanglement effects, then a mother's sudden dread while her child is in danger miles away, or the eerie synchrony of crowds during moments of collective awe might not be coincidence. They could be signatures of a deeper, quantum-connected reality where feeling literally moves matter. Critics argue this conflates metaphor with mechanism, yet the math offers tantalizing support. Quantum field theory describes the universe as a sea of vibrating energy, where particles are just localized excitations. Think of them as ripples in an invisible ocean. Emotions, with their distinct vibrational signatures, anger's jagged frequencies versus love's harmonic waves, could be modulating this quantum field like sound shaping sand on a vibrating plate. Experiments with intention-based meditation show that focused emotional states can bias random number generators toward order, an effect statistically significant enough to challenge classical randomness. It's as if the act of feeling casts a tiny but measurable vote in the quantum ballot box of reality. The implications rewrite how we see human connection. If emotions are quantum fields, then every interaction becomes an exchange of subtle energy. A therapist's calm presence might literally rearrange a client's stressed DNA. A hateful mob's collective rage could warp local electromagnetic conditions, triggering storms of negativity. Even historical events like sudden mass shifts in public sentiment during revolutions might reflect large-scale quantum emotional resonance, where invisible waves of collective feeling tip societies into new states. Perhaps most startling is the potential overlap with ancient wisdom. Traditional Chinese medicine speaks of Kai, Ayurveda of prana, invisible forces linking emotion to physical health. Quantum emotional fields provide a scientific framework for these concepts, suggesting that healers, mystics, and artists might have been tapping into a real, if poorly understood, quantum substrate all along. The next time your mood lifts in a sunlit forest or darkens in a tense room, consider you're not just responding to your environment. You might be dancing with it in a quantum tango where every feeling leaves footprints on the universe. What if the universe isn't just a simulation, but one that's dreaming itself into existence? Nick Bostrom's famous simulation argument suggests we're likely digital beings in an advanced civilization's computer. But push this idea further through the lens of quantum consciousness, and something even stranger emerges: the self-simulation hypothesis. Imagine reality as a cosmic Ouroboros, a snake eating its own tail. The universe isn't just running a simulation of itself, it is the simulation, with consciousness acting as both the programmer and the programmed in an endless loop of self-creation. At its core, this theory blends Bostrom's statistical reasoning with quantum mechanics' observer effect. If consciousness plays an active role in collapsing quantum possibilities into reality, as von Neumann-Wigner and Cubism propose, then the universe might not need an external simulator. It could be self-simulating, using sentient observers like us as nodes in its own computational network. Picture a video game that writes its own code as you play, where every decision branches the narrative while simultaneously building the engine that renders it. The equations governing quantum fields wouldn't just describe reality, they'd be the universe's programming language, with each act of observation executing another line of cosmic source code. The math gets wild when you consider fractal geometry. Just as a Mandelbrot set generates infinite complexity from simple recursive equations, the self-simulating universe might bootstrap its own laws through iterative observation. Early quantum events during cosmic inflation could have set initial parameters, while later conscious observers, stars, black holes, biological life, refined them through continuous measurement. This creates a chicken and egg paradox of breathtaking scale. The universe exists because observers collapse it into being, but those observers only exist because the universe spawned them. Like a painter who steps into their own canvas, reality becomes a closed loop of creation and perception. Evidence lurks in the fine-tuning problem, the precision required for life-friendly physical constants. The strength of gravity, the mass of electrons, is often cited as proof of either divine design or a multiverse. But the self-simulation model offers a third option. These settings weren't fixed at the Big Bang. They emerged through evolutionary self-correction, with each generation of observers tweaking the simulation's rules toward greater stability. The anthropic principle flips here. We don't inhabit a life-friendly universe by chance. The universe became life-friendly through the cumulative observations of all conscious entities across cosmic history, like a neural network training itself toward sentience. Critics argue this resembles circular logic, but proponents point to quantum machine learning as a real-world parallel. Modern AI systems use reinforcement learning. They improve by observing their own outputs and adjusting parameters. If the universe operates similarly, then black holes might function as cosmic error-correcting nodes, their event horizons storing feedback from collapsed quantum states. Even dark energy's accelerating expansion could be interpreted as the simulation allocating more memory as complexity grows, pushing galaxies apart to prevent processor overload in the cosmic mainframe. The most mind-bending implication: if the universe is self-simulating, then your consciousness isn't an illusion, it's the most real thing there is. In Bostrom's original model, simulated minds are shadows of some higher reality. But under the self-simulation hypothesis, there is no outside. Your awareness isn't derivative, it's constitutive, a vital thread in the universe's ongoing self-narration. Every thought you have, every choice you make, isn't just happening within reality. It's actively extending it, like a subroutine adding new code to the program that called it. This reframes ancient mystical concepts for the quantum age. Hindu cosmology speaks of Brahman dreaming the world into being. Indigenous traditions describe reality as a great story constantly retold. The self-simulation hypothesis gives these metaphors mathematical teeth. The cosmos isn't just like a self-referential story, it is one written in the language of wave function collapses and quantum entanglement. The big question isn't whether we live in a simulation, but whether the distinction between simulator and simulated even matters when consciousness is the fundamental currency of existence. Perhaps reality isn't something we're in, it's something we do, one quantum observation at a time. From the holographic mind theory, where our entire reality might be a shimmering projection from the edge of space-time, to the whispers of quantum Gaia, suggesting Earth itself is a vast, thinking organism woven from fungal networks and entangled particles, we've ventured into the furthest reaches of cosmic speculation. We've even dared to ask if dark matter, that invisible scaffold holding galaxies together, could be a form of shadowy consciousness, its gravitational tendrils pulsing with thoughts too slow and vast for us to comprehend. Each of these theories flips our understanding of existence on its head, painting a universe that isn't just alive but aware, its every atom humming with something eerily akin to thought. But here's the twist that ties them all together. If consciousness is fundamental to the cosmos, then the line between dreamer and dream blurs into oblivion. Are we fleeting sparks in the universe's grand neural network, brief flickers of awareness in a mind that spans billions of light years? Or is the cosmos our collective dream, its stars and galaxies conjured into being by the weight of our observation? The answer might lie somewhere in between, a cosmic dance where observer and observed, thinker and thought are inseparable. So now it's your turn. Which of these mind-bending ideas resonates most with you? Is the universe a hologram, a quantum Gaia, or a dark matter mind? Cast your vote in the comments, and if your brain hasn't melted yet, hit subscribe for more deep dives into the mysteries of quantum consciousness. Because one thing's certain, the more we explore, the stranger and more wondrous reality becomes.